Well, hello, everyone. My name is Eric King. I'm the Senior Director of Operations here at Schmidt Ocean Institute, and I have the pleasure of addressing you and answering some of your questions live from San Juan, Puerto Rico, where I'm with the research vessel Falkor 2, after the ship has just returned from our inaugural 40-day shakedown science cruise into the mid-Atlantic. And we partnered and collaborated with a group of teams of scientists from all over the United States and internationally. And we had a great opportunity at the end of that first shakedown cruise to sit with them and to begin thinking about what's working and where we can already start making some improvements in the coming years. But more about that later. I'd like to thank you, Allison, for hosting and moderating and facilitating. And I'd like to turn it over to you for some of the instructions and the technical details of this particular Waypoint session.
Thanks so much for joining us, Eric, and thank you for that warm welcome. I hope everyone had a chance to watch the video before joining us of Eric's tour of Falkor 2. I just have a few logistical announcements before we get started into the question and answers. If you would like to ask a question of Eric about the vessel, please use the Q&A icon at the bottom of your Zoom screen. We have also enabled closed captioning, so you can turn it on or off using the icon on your Zoom screen. And as you heard when you joined, this session is being recorded so that you can revisit it or share with friends and colleagues soon. It will be posted on the Schmidt Ocean Institute website in just a few weeks for it to be available for you. So Eric, let's dive into some questions, and I encourage all of our participants to use that Q&A box and get some questions to Eric of your own. Eric, I thought we would start with a little bit of a lighthearted question since you're on the vessel. What is your favorite part of Falkor 2 and why?
Okay. There's so much of Falkor that I have to think about this for a couple of brief seconds, but at 110 meters in length, that's about 363 feet, there's a lot of ship, and there's a lot of places to call favorite. But considering I was with the ship for the design, build, construction over the better part of the last couple of years in Vigo, Spain, I'd say it's probably our outdoor lounge. And so why the outdoor lounge? It's not a scientific space. There's no data sampling from this particular location, but it's a convening area. It's a space that we've added to the vessel that's multi-purpose. It's for scientists, it's for the researchers, our partners, our crew. It's a place where we can do actual work. We're set up to facilitate data management or networking from this particular location. It's a place where there's socialization. There's a place for events. You can look down onto the aft deck of the ship, 900 square meters of open deck space where we can place modular control vans or laboratories or storage containers. We can watch gear and equipment being launched over the side. And then we can also use the location for barbecues or for outreach or for public engagements with the communities that we're going to be visiting. So it's a multi-use space, and everyone will have their own unique favorite place when they go on board the ship, I'm sure, over the coming year and the decade. But for me right now, it's this magical area that we call the outdoor lounge that we installed.
Excellent. It is a pretty great space, and I love hearing that it's near and dear to your heart with such enthusiasm. Turning over to some more technical questions, is it possible to deploy a scientist-owned mooring system from the ship, such as an Aquadopp currentometer or an SBE-37?
Well, I'd say first, almost anything is going to be possible from this ship. And the reason I say that, in all seriousness, it's a tremendous vessel. And the station keeping capabilities, the number of over-the-side cranes, the handling equipment that we have installed, and that was already embedded into the ship. The amount of over-the-side handling, deployment, and recovery gear that we can install, either scientists own or rented from partners or collaborators, is truly tremendous. And we have embedded inside the ship an area called a moon pool, which will allow us to, in the cover and protection of the ship structure, launch and recover systems, whether they're remotely operated vehicles, autonomous vehicles, CTD, water sampling systems, do that in the security of inside the ship. But outside of the ship, on the aft deck, it's really almost limitless what we're going to be able to launch and recover. And some of these systems, the particular instruments that you're referring to, they're networked and they're cabled, a lot of them. And some of them that aren't cabled, that are actually on mooring systems, we'll be able to have that capability, or we have actually that capability. But the network, all throughout the interior of ship and the interior of the aft deck of the ship is networked as well. And what I mean by networked is we can tap into and control various deployed systems through the science computer system that we've added to the ship, a very robust, comprehensive system that connects the entire vessel from the bow to the stern, all the science data systems that we've embedded and that we are anticipating and hoping that the science community is going to be bringing to the vessel over the coming years.
Excellent. And speaking, you just spoke about things we kind of throw over the side or deploy, but we have a question about the equipment that is mounted into the hull of the ship, which obviously stays with the vessel instead of being deployed. Could you talk about that equipment?
Yeah, so there's a couple of different areas that perhaps the question is seeking some answers. One is the sensors, and it's the scientific sensors that we've added. Now, when we acquired the vessel, and we repurposed the ship to give it a new life after its 10 years of supporting the offshore energy sector, it did not have scientific sonars or scientific echo sounders or multi-beam echo sounders, but we've added those. We've added a very detailed, robust suite of multi-beam echo sounders for mapping the seafloor from just a few meters under the keel, that's the bottom of the ship, all the way to the deepest part of the ocean, and roughly that's around 11,000 meters. And in addition to being able to map the seafloor, we can also study the water column, we can look at currents, and we can also look at the sub-bottom down to several hundred meters. That means below the seafloor. And that's a capability that we did not have before with the previous ship. And we've added all these new science systems into a massive structure that hangs below the ship, a big steel structure called a gondola. And a gondola is just a steel structure that contains these and is able to mount these sonars. Well, that's not all we've done, of course. The sonars are below the vessel, but what about inside the vessel for launching and recovering gear and equipment? Well, we brought our own remotely operated vehicle, Sebastian, that we designed and built back in 2015 and 16, that's capable of 4,500 meters of depth. That now lives inside the ship when you want to deploy it, and we can deploy it for hours or days at a time. We open up the side of the ship to these massive doors, and the vehicle is deployed out of the side of the vessel and lowered down into the water, and it's all controlled from inside the ship from our mission control room. But we've also added a science mast up forward. And the science mast is essentially a structure that's also networked, and scientists can come and add really a robust series of atmospheric or meteorological sensors that we can get real-time data from. Or we can also launch and recover gear from the stern of the vessel, where we've added a 30-ton capable A-frame for launching and recovering gear over the side, or essentially the stern of the vessel. And on another part of the vessel, on the port side, the list goes on, Allison, you asked the question, we can launch and recover other scientific gear and equipment that we can add to a specific cable that's already in place. And right now we have what we call a CTD water sampling rosette system, where we can reach depths of around 5,000 meters to collect water samples and also to understand the conductivity, the temperature, and depth of the water that we're sampling.
Excellent. That was quite the breadth of sonars and equipment in that answer, Eric. I really appreciate it. But one thing you did not mention was the helideck on board Falkor 2, and we have a question about whether the helideck is operational, and if it's not operational, how does SOI plan to make use of that space?
Well, fortunately for a helideck, the deck itself is a static platform. It's a steel structure. So in a sense, it's always operational. But it really depends on what you want to do with the helideck. Now, perhaps in the world of ocean science and atmospheric sciences, we're talking about using autonomous aerial vehicle systems, something that we're familiar with from Falkor over several years of operating vehicles from the aft deck of the ship. But now with this helideck that you're talking about, we're essentially looking at it and calling it a flight deck. Now this flight deck can handle things as large as a big Sikorsky helicopter. And if you're in the world of big helicopters, you know that these are large offshore crew helicopters, but I can't imagine that an autonomous aerial vehicle will be quite that large. But we've added features to this area where the helideck is, so that scientists can bring containerized laboratory vans and plug those vans or those 10 or 20-foot containers into special ports for networking into the science computing system. We have stations throughout the vessel where they can monitor their aerial vehicle systems. And then at some point, we'll be able to bring real helicopters, meaning with people in them, to the vessel. Now, the vessel is designed to carry helicopters or land helicopters, and we're going through that process right now to recertify that for helicopters that are occupied by humans.
Great. I'm glad to hear that the space is being well utilized. We have a couple of questions related to the data that will be collected on board Falkor 2. And the first question is, does the sonar data that we collect contribute to the Seabed 2030 project? For those of you that don't know, Seabed 2030 is a global initiative to map the entire seafloor by the year 2030. Does SOI contribute the data collected by Falkor 2 to this project?
The short answer is yes. We do, and we have been, and we've been a partner with the Seabed 2030 project for several years now. And we don't just contribute the data that we collect from mapping the seafloor to make it publicly available. All the data that we collect, whether it's from the multitude of sonars that we have on the seafloor, it's could be sensors and video and still imagery that we're collecting from our remotely operated vehicle. Perhaps it's meteorological data that we're collecting from our science mast that sits on top of the ship's wheelhouse or bridge. All of the data that we collect eventually gets transferred and shared openly in what we're really referring to as, well, what's our new term, Allison? We're no longer calling them repositories. We're now calling them the centers, that's right, because they're really access points. And that's what we're trying to achieve, is accessibility of the data that we're collecting. So yes, Seabed 2030, a great program, and we're going to continue to share the data that we collect from the seafloor with that organization. So at one point, hopefully by year 2030, the majority or most all of the seafloor will have been mapped to at least a resolution that's good enough to go and plan future expeditions and missions.
Yes, and it's great to hear that SOI is a partner of that initiative and also contributes its data. We have another data-focused question from our audience members, and they say, it looks like you will be sailing to some remote places, and I know you have mentioned the atmospheric sensors on board the ship, do you have plans to expand the data collection in these remote areas so that you can take advantage of collecting more data, perhaps where not a lot of vessels have been, or where there's a data desert, let's call it? Will we be collecting more data in these places?
Again, the short answer is yes, but then I'd like to go back to the person that submitted the question, or the people that happened to submit that question, and turn the question to them and say, what data are you looking for? The reason I say that is because Falkor 2 and bringing Falkor 2 online this year and in the coming years is really a marathon. It's a journey. And the sensors and the systems that we have installed today are not necessarily the only sensors that we're going to have over the coming years. When we look back on how Falkor, our original research vessel, evolved over the decade of use, at the time that we donated the vessel to the Italian research organization, it was quite a different vessel from what we first put to sea. And the reason is because it evolved, and it evolved through our partners and collaborators, through cruise after cruise, and feedback from the scientists. So again, the short answer is yes. Those data deserts, and the ocean is full of them. It's not just the surface, of course, it's the water column, and it's on the seafloor. Our sensors are going to be operating when we're allowed and when we're permitted all the time. And the data will be, even when we don't have teams of scientists on board, which will probably be very rarely, that data will be streamed and shared and archived with those data centers. But additional systems and sensors, whether they are ad hoc, brought on just for a particular cruise, or maybe they're embedded into the vessel temporarily as part of a broader program with some other researchers and technologists or engineers, I have no doubt the ship will become just a hub of data collection far beyond what it is today.
I love the enthusiasm, Eric. So let us know what you're looking to collect on board the vessel, and Eric will make it happen. I'm going to switch topics a little bit, and we have a few questions about life on board the vessel and at sea. And we have an attendee that said they're really intrigued by the color and unique look inside the vessel that they noted on your tour, and they wanted to know how we decided on some of the interior looks or vibes of the research vessel.
Well, from the inside of the vessel, focusing where a lot of the tour was, and outside of what we call the ship's hull color, or happy blue, or SOI happy blue, the idea was to create a slightly different environment than what many researchers may have been used to on the majority of research vessels. There are some spectacular ships that are being built today. There's amazing ships that are sailing that have been built decades ago. But we try to take a little bit of the best of all worlds and create laboratories that were functional and aesthetically pleasing. But then on each deck, instead of having the same theme and color of fabrics or trims, the idea was, as you move through the vessel, you're like moving through your own workspace, whether you're home and you're in different spaces inside your own home, and then your laboratory or your offices where you're working hands-on. So you'll find in the lounge areas, every one of our lounges and on the lounge deck and where people eat at the mess has a completely different feel than the cabins, or perhaps down on the aft deck in the hangar or in the laboratory. And we had quite an involvement from our founders. They were certainly involved in helping to identify the proper colors and choices that made it an aesthetically pleasing place to work, that helped to reduce some of the stress that can occur when you're at sea for weeks or months at a time, and also when you're working with a lot of people. You remember, when you're going to sea with just 10 or 20 people, it's quite a bit different when you're going to sea with maybe 30 or 40 or more people. And you have to make the interior spaces such that people have a place to go and to relax and to step away from work every once in a while, but then also know that when they're in their working environment, it's a place of business where they really need to get the work done and collect that data.
Yes. And speaking of the working environment and collecting the data, we have a question about where scientists have space to work on board the vessel. Someone noted that they didn't see a lot of desks in the tour that you gave, but I know we do have space available for scientists to meet and work. Could you talk a little bit more about the working spaces on board Falkor 2?
Sure, we have in our laboratories, we have 8 different laboratories on the ship, and all the laboratories have bench space. Most of those bench spaces are just, they're your typical laboratories height. It's just a little under a meter in height. And we have a computer electronics lab. Those are normal desk heights. And we have ergonomical chairs for all those desk spaces and those working benches. And then we also have a conference room where we can seat probably about 15 people in that area. We have lounges where people can go and bring their laptops and set up and work at small picnic tables, or they can go outside in the outdoor lounge, and we have a seating and table space out there if the weather is nice, or even if it's not so great, we have an area that's semi-enclosed. And then we have a mess room as well that can accommodate up to 60 people. And we've arranged our mess room so that there are some private areas. So if you want to go up and just step away for a little bit, you can set up your laptop and work. So from a combination of these 8 different laboratories, a computer electronics lab where you can work at normal desk height, conference room, even in some of the cabins, there are small desks if you need to have a little bit more privacy, our lounges and our mess and the outdoor lounge. There's a variety of places where people can have some workspaces.
Great. Yeah, it sounds like there's no shortage of places to put your laptop and work. Another important part of being at sea is the food. And we have a question from an audience member. Is the vessel planning to grow any food on board the vessel?
Well, I like answers that I can give a short answer, yes. I'll give that one again. And we're going to carry over from some of the food growing a little bit that we did on board Falkor, where some herbs were grown, and we're certainly going to work on that again. But we've definitely been talking about that. We don't have anything set up today, but our chefs are certainly interested in trying to see what they can grow at sea. And I'm confident over the coming years, you'll see some type of garden where that's allowed. But there are some restrictions. When you do go into ports around the world, some ports don't allow agricultural products. So we have to be mindful of where we're going in the world. But that's a great question, and I know our chefs would be really eager to begin growing some food to serve to the scientists and to the crew.
Yeah, sounds delicious. We have a question about how large the ship is. I know you've talked a lot about how long it is, but we have a question about how tall the vessel is and how many levels of living space are on the inside.
Well, of course, with a ship, you don't just go up, you also go down. And so overall, there are around 7 different levels. And it all depends on how you're counting. And if you're counting engine rooms, if you're counting the bridge and a space that's above the bridge. But overall, we have the main deck of the ship, which is primarily all laboratories. So the science and business of the ship. And this is how the modern conventional research vessels are constructed. And even though this vessel is just 10, 12 years old, we took a page from that playbook. And so the entire main deck is dedicated to science. Then the next deck above is living accommodations. And then we have what we call the public space, and that's our lounges, and that's the mess area. And then we move up another deck, and then we have some ship's offices and some additional accommodations in the next 2 decks. And then to the bridge, the full expanse of the bridge deck. So there's plenty of places to go around the ship. And for those that are challenged going up and down all those stairs, don't worry, we have an elevator that can take you from the engine room all the way up to the accommodation spaces to ease your vertical transportation.
Excellent. And I wonder if you might want to expand on that a little bit, Eric. We have a question about, is the vessel accessible for people with mobility issues? So naturally there are parts of some of the vessel that are not, but we do have an elevator. So maybe you could talk a little bit more about how people can get around the vessel.
Right now, the best way is virtually. We've created some virtual tours of the ship that allow you to, aside from the video that you may have watched of me walking around the vessel, you can click from room to room to room, from space to space, the aft deck, the laboratories, and some of the other, the science business part of the ship. But that's kind of a static program. What we have done, and we've really, instead of just trying to reach a few, we were trying to reach the millions. And we're doing that by what you may have heard from Jyotica's previous presentation, is through almost telepresence in essence. And so telepresence is a system of being able to participate in a science expedition, one of our cruises, from anywhere in the world, from the convenience of your laptop, whether you're a scientist, an engineer, a roboticist, a technician, or an armchair scientist, an oceanographer, just a visiting public, school children. You'll be able to watch where we're going and what we're doing in real time. And we've demonstrated that again on our inaugural shakedown cruise just to the mid-Atlantic. But we've installed cameras throughout the entire ship and all the laboratories, outside of the vessel, on the aft deck where all the equipment's going to be installed, inside the hangar, of course, around the remotely operated vehicle, on the helideck, on the science mast, on the top of the ship. We really wanted to bring the ship to the broadest public as possible, to have access as broadly as possible. And through this telepresence, through this camera system, through the online connection, watching us on YouTube, or maybe a Facebook or some other social media platform, will allow us to reach corners of the world that we just started reaching just a few years ago with Falkor, but now on a scale that we didn't think possible.
Excellent. Thanks, Eric. And we'll be talking about that a little bit more tomorrow with our Ship to Shore program. So if you have additional questions, feel free to join us tomorrow. You mentioned that a cruise just ended, and I know in a few days we'll have a new set of scientists coming on board, and we have a question about how to mobilize for a research expedition. Do you need an additional boat, a small boat that can come to the port? And how do you get shipping containers on board the vessel?
We were so fortunate with this new ship, with Falkor 2, and the ability to mobilize, meaning bring science gear and equipment onto the ship or off the ship in some of the most remote parts of the world. And how we're doing that is through the use of, and we're doing that right now here in San Juan, Puerto Rico, USA, is through this massive crane that we have that was already installed in the ship that we've brought back into service. We can lift these 20-foot or 40-foot shipping containers, portable laboratories, other gear and equipment that the scientists may need on board, whether additional winch systems, launch recovery systems, moorings, and we don't need any shoreside infrastructure. We just need a dock to get to. We're almost self-sufficient, and we're demonstrating that right now for the first time. And that's something that we have been looking for many years, and that was some of the feedback we have received from the scientists. That's also allowing us to do something else for the first time. We are pre-mobilizing for cruises, for expeditions, several expeditions from now, especially when we're going to be working in some really remote areas like Galapagos. Galapagos is an example where there's no place to bring the ship to the dock, so we have to have scientists or crew ferried from Port City to the vessel. So we have to pre-mobilize. We have to bring gear and equipment well in advance of that particular expedition, and we're doing that right now. So having that capability to move these large containers or gear and equipment and winches or over-the-side handling gear and equipment and systems on and off the vessel on our own is really a game changer for us. And it's going to allow us to operate in parts of the world where we weren't able to operate previously. However, saying that, it's a bigger ship and it sits deeper in the water. So there are some draft constraints, and we need around 31 feet of water to bring the ship to a dock. And there are remote ports in the world that have this capability. And of course, modern ports, most of the modern ports of the world have this capability as well.
Excellent. Well, thank you so much, Eric, for taking the time to share more about Research Vessel Falkor 2 with us. And thank you, everyone, for participating and for your wonderful questions. I think Eric really enjoyed answering them as much as I enjoyed asking them. So I really appreciate your thoughtful questions. And we will be back tomorrow with 3 more sessions. So please check the symposium website for more information and join us tomorrow. And Eric, I'll leave you with the final parting words about the new Research Vessel Falkor 2.
I'll sum it up in 2 words and then finish it with a sentence. Dream big. So what do I mean by dreaming big? This is a big ship and it has a lot of capability. It has far more capability and capacity than we had with Falkor. And with that comes new opportunities. There are potential projects, there's potential missions and expeditions and collaborators that we never thought possible based on what we had before. But now we have this unique asset with moon pools and over-the-side handling equipment and helidecks and station keeping, the ability for the ship to remain in a virtual position over the seafloor within just a meter variance is something that the science community, once they become more aware of these capabilities, we're confident that they're going to bring to us ideas and new possibilities of working in some of these remote areas, doing serious science, collecting data from the deepest part of the sea, or perhaps even some of the shallowest part of the sea that we hadn't thought possible at this level, at this scale. So think big, dream big.